Today we're going to be learning about linear equations and understanding what a linear equation is. So the key in linear equation is, see how the word has the word line in it? That means that a linear equation forms a line. So we're just going to highlight that because it's important. Linear equation makes a line. So if you end up with something that's not a line, you're doing it wrong. So it says we say it's a linear equation in standard form if ax plus by equals c, where a and b do not equal 0. So basically, it's in standard form if you have x plus y equals a number. And a linear equation has that property where it can be written in standard form. So here, what we're going to do is just determine if it is linear, and if so, we are going to graph it. So remember, thinking back, it needs to be x plus y equals c. This is x plus y equals the number, so this one is linear. And we're just going to type that. Linear. Okay. I'm looking at b. B is not linear. The reason why is because this guy right here, it's not allowed to have an exponent. So whenever you have exponents, it is automatically going to be nonlinear. Right, because that's bad. So then what we say is if it's not doesn't form a line, you just say nonlinear. So this one, because it's nonlinear, we don't have to graph it. We're done. But this one is linear, and so we're going to graph it. And how we graph it is we are going to solve. So actually, we're going to do this a little differently. We're just going to get y equals because I know how to make a table of values. So remember, it needs to be y equals something. So in order to make it y equals something, I need to rearrange this equation by moving the 5x to the other side so I can have y by itself. So I'm just going to do that now. I'm going to minus 5x from both sides. And remember, when you minus 5x, it cancels on the left. And over here, they're not like terms, so they're actually not even going to combine. So my new equation is y equals 10 minus 5x. And what I'm going to do now is make a table of values using that equation. So remember, I'm going to make that t. Oh, that is an actual thing. X is over here. And I'm just going to choose 0, 1, 2. I'm not going to go through all the values this time because I want to just get a quick graph. I only really need 2 points to graph. So if I plug 10 into this equation, or sorry, 0 into this equation, I'm going to have 10 minus 5 times 0, which is just 10. So my first point is going to be at 0, 10. My second equation is if I plug in 1 to the equation, so 10 minus 5 times 1 is 10 minus 5, which is 5. So my next point's out 1, 5. And then finally, we do 10 minus 5 times 2, which is 10 minus 10, which is just 0. So I'm going to have a point at 0, 10, 1, 5, and 2, 0. Now looking here, um, 0, 10 is not going to fit on my graph because it ends up being right up here. Well, I mean, we can put it there, but it doesn't fit. And then 1, 5 is right there. And then I have 2, 0, which is right there. And that's all we got to do. And then you just simply connect the dots. And remember, it's a line, so you want it to kind of extend a little bit more. There you go. That's our line. So remember, again, to recap, you rearrange the equation so you have y by itself. And then you just plug in x's into the equation. You only need to plug in 2. I plugged in 3, and then graph the 3 points. The concept we're going to talk about is discrete versus continuous, which is something we have actually already talked about. So remember, discrete is where the graph has unconnected points, and the continuous is an unbroken line or curve, so the dots are connected. So in this problem, we're going to give the domain a range and determine if it's discrete or continuous. So Kyle opens up a video store and pays $2 for each DVD, which is given by f of x equals 2x, where x is the number of DVDs. So what we're going to do is we're going to create a graph, table of values. And we're going to talk about what each of these values should be. So I have 0, and then over here I'm going to have 2x. And let's just choose some points. Let's do 0, 1, 2. Actually, you know what? We're going to just use a text box. 0, 1, let's do 5 and 7. I could have chosen any values, but I want to get a good idea of what this is. So if those are my inputs, then to calculate my outputs, I have to figure out, well, what's 2 times 0? Well, 2 times 0 is 0. What's 2 times 1? 2. 2 times 5, 10. 2 times 7, 14. If you think about it, this equation actually represents how much he's paying for a DVD. So if he buys 0 DVDs, then yeah, it's going to make sense. He's going to make 0 money, or pay 0 money. If you buy no DVDs, you don't pay anything. If you buy 1 DVD, though, each DVD is $2, then yeah, you are going to have to spend $2. If you buy 5 DVDs, 1, 2, 3, 4, 5, then you're going to have to spend $10. And that's actually going to max out our graph. But we could expect that if I bought 3 DVDs, I would pay If I bought 2 DVDs, I'd spend $4. And if I bought 3 DVDs, I'd spend $6. And this is actually needs to be over on the other side. This is why it's important to count people. Because 4 would be 8, and then 5 would be 10. So it's 5 actually over here. So there we go. So now we have to identify the domain and range. So the domain of this function is going to be 0, 1, 2, 3, 4, 5, and then it just continues, right? Because he could buy 1,000,000 DVDs. And if he buys 1,000,000 DVDs, then what's the range? Well, the range is the y value, so 0. And then it's counting by 2. So 2, 4, 6, 8, 10. And then again, you can buy an infinite amount of DVDs. Just keep going. Now we really have to decide, well, is this continuous or discrete? So remember, discrete means the dots aren't connected. So let's think about, what does it mean if I connect these dots? Well, if I connect these dots, I'm not saying that I could buy half a DVD, but can you buy half a DVD? No, it's not going to work. So this graph is actually going to stay discrete because it doesn't make sense to connect the points, given that what this graph represents. So discrete, because we can't buy half. I'm just going to move this. Okay, and that's all that is for that problem. So next one, we got Ashlyn, who rents a booth to open an ice cream stand. She pays $1 per hour for each hour of operation, which is given by f of x equals x. So same thing as last time, we're going to make a table of values. And we have x. And then f of x is just equal to x, which is kind of cool because what this means is that whatever number I put over here is going to be the same number on the other side. So if it's 0, then what I get out of the function is also 0. If she rents it for 1 hour, then she pays $1. If she rents it for 4 hours, she pays $4. If she rents it for 8 hours, she pays $8. And if she rents it for 10 hours, she's going to pay $10. So this time I went a little bit crazy with it. I got a few extras on there. But, let's see. Let's graph these points so we can start getting an idea of what this graph is going to look like. So 0, 0. She doesn't rent it. She doesn't pay any money. She rents it for 1 hour. She pays $1. 4 hours is $4. Did it again. And it just kind of keeps going, right? It follows this pattern. Some of these dots are out of place. There you go. Up till 10 hours, she's going to pay $10. And then we got to connect the dots. And there we go. And sorry, I kind of skipped a step, but the reason why we connect the dots is because it is possible to rent it for half an hour. Since it's possible to rent for half an hour, it is going to be continuous. So again, you just got to think about these problems as, can I break it up more? And if you can, it's going to be continuous. If you can't, it's discrete. So now we got to talk about the domain and range. So the domain of dysfunctions are the possible x values. So the possible x values are going to be between 0 and infinity. Oops, I don't know why I broke it up. I think there's an infinity symbol. There we go. And the reason why is because this family, me and Ashley, could rent this for her whole life, and then her children could rent it, and her children's children. There's actually no possible end and no required amount of time. She could rent it for a day, she could rent it for a year, she could rent it for half an hour. Either way, that's how it would be represented, and vice versa. The range is going to be written the same way, because remember, the range is identical to the domain. So it's 0, and again to infinity. And then kind of trick question, but let's remind us again, this graph is going to be continuous because, again, it goes back to the idea that I can connect those dots. And there we go. That's it for notes.